It is a cosmic crazy thrill ride of exemplifications. While Venus was at first remembered to be Earth's astronomical twin, it was later recognized as its toxic stepsister. Our adjoining planet is suddenly associated with holding on to life again. Did the Soviets already have this thrilling hypothesis in their subconscious when they sent no less than 28 investigation tests to Phoenix between 1961 and 1983? Well, who knows, but it's undeniably true that the aggressive Venera program was by no means just delegated with success. It was marked by crashing disappointments, especially toward the beginning. Regardless of this, the mission also provided notable new bits of insight, and one of them is now coming back into focus with regard to the controversial question of life on Venus. Some dates have probably been carved forever in the memory of every space fan. Of course, there is July 21, 1969, the day when Neil Armstrong and Buzz Aldrin became the first humans in history to set foot on an alien celestial body. However, much like the first successful moon landing on April 12, 1961, it's extraordinary. After this, that was the day when Yuri Gagarin became the first man in space. But did you know that December 15, 1970, also marked a remarkable achievement in space travel? In fact, the Soviets accomplished something that no one had ever done before with Venera 7. They made the first soft, or in their case, automated landing on the surface of another planet. As you would expect, it was Venus that had become the focal point of Soviet research interest. But then it was far from the successful realization of this project. In truth, the origins of the Venera program date back to the early 1960s, yet the first test launches all ended in outright failures. To understand how much our understanding of Venus has changed since then, it's worth investigating the following. After it was revealed in 1961 that the Soviets wanted to send 2 tests to our neighboring planet, the West thought that these were meant to have the ability to float in an ocean. Yes, you heard right. While the extremely hot Venus, with its toxic clouds of sulfuric acid, can certainly be known as a hellish planet today, it was still believed until the mid-1960s that our planetary sister resembled a primitive Earth covered by oceans and forests. An undoubtedly intriguing concept, but one that has since changed somewhat. Although Venus and Earth are indeed similar in terms of size, mass, density, and internal structure, like one planetary egg inside the other, the differences elsewhere couldn't be more dramatic. The Earth's average temperature is 15 degrees Celsius, yet on Venus, the thermometer rises to an average of 464 degrees Celsius. The ocean on Venus that was thought to exist before the launch of Venera is also absent. In reality, no surprise, after all, the vast planet's cloud layer isn't a previously thought water cloud but a deadly cloak that contains not just sulfuric acid, but also aerosols containing chlorine and phosphorus. In light of this, it's not too bad that Venera 1 didn't carry an ocean lander when it was launched in 1961. However, what was even worse was the fact that contact with the probe was lost entirely just a few days later. Despite this, the silent spacecraft is officially considered to be the first artificial object to enter the domain of Venus on May 20, 1961. The rocky road to success honestly provides little comfort and can't hide the failures that followed. While the USA succeeded in sending the first probe to Venus, Pioneer 2, on December 14, 1962, which also sent usable data back to Earth, the Venera program initially only attracted attention due to further failures and serious communication issues. But then, since March 1, 1966, Venera 3 managed to adorn itself with the title of being the first space probe to crash onto the surface of an alien planet. The praise from those in charge when Venera 4 finally managed to transmit data successfully from the atmosphere of Venus in 1967 must have been deafening as well. It gave the Soviet Union the long-awaited pride. But undoubtedly, it was not plain sailing for the Soviets either, as we now know that the atmospheric pressure at the surface of Venus is 92 bar. The members of the Venera 4 mission didn't know about this reality accordingly. The test slid more leisurely than anticipated, which eventually forestalled it from arriving at the planet's surface inside the arranged working time. Notwithstanding this, the information it did gather gave significant new insights, including that the temperature 25 kilometers above the surface is 270 degrees Celsius and that the air of Venus comprises fundamentally of carbon dioxide, alongside limited quantities of nitrogen, oxygen, and water vapor. Venera 5 and 6, launched in 1969, too succumbed to the enormous pressure on Venus. But since the tests were able to send information about the climate to Earth, again, the double launch was reflectively considered a triumph. 2 crushed space tests later, the event had finally come for Venera 7, and as mentioned at the beginning, on December 15, 1970, it became the first space test in history to successfully, that is, safely land on the surface of another planet. What did the Venera tests find on Venus? Intended to endure a strain of 180 bar, Venera 7 communicated a weak motion toward the examination stations on the planet for just shy of 25 minutes. Simultaneously, it gave specialists the information that temperatures at its arrival site were searing, 475 degrees Celsius. It also provided the data needed to create a subsequent test that could explore our extreme sister world more thoroughly and with success. When Venera 8 arrived on the day side in July 1972, it found that the surface of Venus was basically as bright as a cloudy day on Earth. And even though only 11 seconds of the 50-minute data transmission from the surface were used, the specialists now knew that ammonia exists on Venus and that potassium, uranium, and thorium are found in its soil. But the investigation of Venus was still accompanied by a significant disadvantage. Later, it hadn't been possible for us to get a direct look at the planet's surface. However, after Venera 8 had shown that landing on Venus was possible in principle, Venera 9 and 10 finally gave us the first pictures in October 1975. The low-resolution, black-and-white pictures showed a somewhat smooth area sprinkled with stones and pebbles. And really, Venera 11 and 12 should have brought a bit more color into the Venus game. 3 years later, however, tragically, the camera's cover would not fall off. Thus it was that mankind had to wait until March 1982 before Venera 13 and 14 gave the first high-resolution color pictures of Venus. In the same breath, the microphones of Venera 13 also captured the sounds of the Venusian wind, allowing us to listen to the sounds of another planet for the first time. In 1983, Venera 15 and 16 once again turned their test attention to mapping the planet's surface. But it was the Magellan test, launched by the USA 6 years later, that gave us the first global map of Venus from 1984 to 1986. The Soviets completed 2 more successful Venus programs with Vega 1 and 2, but these planetary outings happened about 40 years ago. However, if the Russian space organization Roscosmos has its way, the long delay will soon be over. After all, the Venera legacy is set to continue sooner rather than later. More specifically, the Venera D mission is planned for the end of 2029 at the earliest, with a test comprising a satellite, a landing stage, and a balloon floating in the atmosphere. Venera D will investigate the climate of Venus, study any volcanic activity, and maybe even provide evidence that our neighboring planet is home to extraterrestrial life. The subject of life. Before we delve deeper into this fascinating topic, we should briefly address another question. What remains of the Venera test today? Well, since the surface of Venus is typically hidden behind a thick shroud, we can't answer this with full confidence. But, at the very least, it is thought to be reasonable to assume that the immense heat has completely scorched all materials used, parts like cables and seals. Afterward, sulfur dioxide and other acidic gases entered the interior of the tests, burning and oxidizing the metal parts inside over the course of the next couple of weeks. The titanium and steel edges may have also been softened before the sulfur compounds finally infiltrated every crevice and ate away at the once pristine surfaces. And while the tests are probably covered by layers of oxide and dust nowadays, they might even have somewhat merged with the volcanic terrain. Anyway, the valuable metals such as gold and platinum would likely still be present and maybe even visible. Although the same can't be said for the inhabitants of Venus. And that, despite the fact that there is now some astonishing proof that they might actually exist. For example, both the Venera and Pioneer tests have detected only limited quantities of carbon monoxide on Venus, and that despite the fact that solar radiation and lightning activity should indeed produce it in large amounts from carbon dioxide. At the same time, however, hydrogen sulfide and sulfur dioxide were also detected, two gases that react with each other and are not typically found together. On the other hand, there must be a process on Venus, perhaps biological, that maintains a balance between these gases. And then there is carbonyl sulfide, which also exists on Venus and, according to our understanding, can hardly emerge without biological processes. Besides, a recent study concluded that the dark spots in the UV photographs of Venus have spectroscopic features that match those of earthly biomolecules and organisms. The detection of the gas phosphine is also thought to be an indicator of biogenic cycles. And without a doubt, a new study revealed that all the major building blocks of life can endure the extreme conditions of Venus clouds. In this context, the corresponding amino acids appear to be stable even when sulfuric acid is mixed with other chemicals such as carbon monoxide and iron oxide. And though only future exploration missions can show how much our theories and assumptions match the reality of Venus, the expectations of the scientists do not rest solely on Venera. NASA and ESA have also set themselves the goal of visiting our toxic planetary sister again soon. And, if you want to visit our channel again soon, you can now just click on the subscribe button. We would love for you to join our community so you never miss another video from us again. We'll see you soon. I added punctuation to clarify the meaning and make the text flow more smoothly. Let me know if you'd like me to modify anything.